Hello everyone, welcome to the Mechanism Sessional Group project. We have made project on the garage door mechanism. I am Suryansh Patel, roll number 21MF10055. Today I will present my group project with my team members Mahesh Shekokar 21ME30043 and Rishi Dhoble 21ME30053. Our project is based on the synthesis and simulation for a garage door mechanism with no prismatic and higher kinematic pair, and that takes less area to remain open. For mechanism sessional course ME29002, here are the table of content, that is the flow of work we will do. Let's begin. First, we will introduce 3D model of a garage and the garage door, where we will understand the problem, and then we will discuss its mechanism with its various calculation, and finally we will discuss the various innovation we can apply to this mechanism. In our project, we have tried to make a simulation of an automatic manually operated garage door opening mechanism using only revolute pair and no higher kinematic pair. The simulation of a mechanism is done using SolidWorks. Initially, the garage is open, that is, the vehicle is inside, and the garage door is parallel to the rooftop. Now, the mechanism is utilized to move the garage door so that the garage is closed. This is guidance problem, where we want a reserve body entry here to move the closed position to open the position in a prescribed manner such that it does not hit the body of the vehicle. Now let us look at how it works in the opening and closing position. Picture 1. So the opening position with 6 link and 7 joint and 2 designated location in the figure are fixed.
Hello, I am Mahesh Shekokar, and today I will explain the detailed mechanism involved in the opening and closing operation. On the screen, we can see the mechanism and working of the garage door. As one of the link is moving, it helps to open or close the garage door. This mechanism is mounted on the slide walls and do not interfere with the vehicle movement. Only the door move inside the garage to open or close the garage. As we have discussed earlier, there are 6 links and 7 joints, out of which 2 of them are fixed. Now let's have a look at the degree of freedom calculation. We can see the number of links are 6 and the number of joints are 7. As all of them are revolute pairs, so each will have a freedom of 1 summation of this freedom. Should be also 7. After calculation, we get the degree of freedom as 1, so it will move in one fixed direction only. Now let's have a look at the synthesis of garage door to determine the dimensions and angles of the mechanism involved in the dimension analysis. Dimensional synthesis is a type of inverse problem in linkage kinematics where the objective is to calculate the linkage dimensions required to achieve prescribed linkage. Output motion generation is a particular category of dimensional synthesis where the objective is to calculate the linkage dimensions required to achieve a group of prescribed motion. We have considered the open position and solved for the closed door position. Now let's look at the displacement analysis of the problem. And displacement analysis is that geometric relationship between the actuated joints and the output link without the regard to the force. Torques that cause the movement is formulated and analyzed. We can see the relation between different angles so that to obtain the particular motion of the output link with the movement of input link. Next, we look at the force analysis. An analysis will link the respective forces acting at any point of any member or part of a member of a mechanism obtained by using realization of dynamic equilibrium in a plane rigid body subject to external forces within this plane and two internal forces due to its motion in this plane. We can see The calculation for the driving or lifting force to open the door. Hello everyone, myself Rishi Dhoble and I will be briefly discussing about the possible innovation for making the mechanism automatic. It will be favorable to add a motor which can be switched on to rotate a particular link that is cranked here by a certain angle with the help of position sensors to determine the initial and final positions. Since no higher weights are used in our mechanism, so the lifting force, that is the torque required to rotate the crank, will be high. Therefore, the ideal choice of motor here would be a DC servo motor, which can provide a higher torque with precise angle rotation. A servo motor is a closed loop system that uses a position feedback to control its motion between initial and final position. There are many types of servo motors, and their main feature is the ability to precisely control the position of their shaft. The actual position captured by these devices is fed back to the error detector, where it is compared to the target position. Then, according to the error, the controller corrects the actual position of the motor to match the target position. Servos can usually rotate from 180 to 270 degrees, as mentioned earlier. There are two ground number, one ground number, two. So to facilitate easy movement of the garage door, we can use two servo motors on ground number, one on the either side of the door with sensors, being attached to the entry floor and the rooftop to determine initial and final position. Servo motors can be rotated in both directions using microcontrollers having double pole, double throw switches or bidirectional H-bridge DC motors circuits. The mechanism can also be manually operated by attaining a handle at the front part or by manually rotating the crank. Finally, I would like to conclude my report by saying that we have used most of the concept that we have learned in the kinematics and kinematic of machine course and mechanism course. We have made the kinematic diagram of the mechanism and have figured out its degree of freedom. We have used dimensional synthesis, displacement analysis, force analysis to move the door in the prescribed manner. Most of the garage doors have prismatic or higher pairs, so developing a garage door mechanism with revolute pairs only was a challenging task. And finally, we have come with an optimal motor for the automated garage door mechanism. Thank you.